Hey everyone. In this hopefully short video, we're going to go through the for loop in Java. This is a really common piece of syntax, and it's not something that exists in the Python language. The Python language has a for loop, but its job is to go through all the items in a list or some other iterator like a range object. So although you can do with it some of the things you can do in a for loop in Java, it's not quite the same. But this is a really common syntax, especially for looping through arrays. So if you take a look at the screen here, this is the syntax of a for loop. And if you've never seen this before, so if you've done programming in these kinds of languages before, in the C-style languages before, you'll have seen it. If you haven't, it's going to look pretty alien. What I'm doing here is I'm just relating. So over here is a while loop that hopefully looks pretty familiar. You start with x equals 1, while x is less than or equal to 10, print out x, and x++, if you recall, that's the same as x equals x plus 1 in Java. So this is a little counted loop. The for loop is particularly popular for counted loops, but it doesn't have to be used for them. What you can think of here is that you've got an initialization statement, you've got a test, an action, a change, and then you loop back. When I teach intro courses, I call these I-tackle loops. Right? So here's a flowchart for it. Initialize, test, take an action or act, change the loop variable, and then loop back and test the variable again. So I call that I-tackle. What the for loop does is it takes that loop logic and puts it all into the top line. So the initialize, the test, and the change actions are all here, but they happen in the same order that they would if you arrange them this way in a while loop. So what that means is, as the for loop begins, the initialize statement is run one time only and then never again. Then it does the test to see, and if it's true, it goes into the loop body and does whatever the action is. And at the end of the loop body, it does the change. So this arrangement here, the reason why people do this is because this arrangement mixes up. It's like these three things: initialize, test, and change. These are about the loop logic, you know? So up here, initialize sets x to 1, change adds 1 to it, and the test makes sure that it doesn't get too high. That whole logical statement is now in one line in a for loop, like that, separated by semicolons. That's why people like it, because it puts all the logic up here. But it is pretty weird looking, and it violates the usual rule that things happen more or less in the order that you see them up here, because the initialize happens first and then never again. The test happens over and over again at the top of the loop, and the change happens over and over again at the end of the loop down here. So it takes a little bit of getting used to, but you will get used to it fast because it's used everywhere. I have in the week 2 code here, I have the for loop examples. So if I just run this code here, Control-Shift-F10, I believe it is. Here we go. We have 2 counted loops that are doing exactly the same thing. So here's the for loop. Right? It starts at 1, it goes up to 10, and it adds 1 each time. And then it prints it out here. The while loop, you can see it's a little bit more sprawling. It's less compact, the while loop. But it does exactly the same thing. Count less than or equal to 10, count plus plus down here. That's why people tend to prefer the for loops. So if you wanted to make this count by 2s, you would go count plus equal 2 there. And then the for loop now will be a bit different because it will count 1, 3, 5, 7, 9, adding 2 each time. If you wanted to make it count higher, you change this, and so on. Okay, so that's really all there is to it, the for loop. There is one little gotcha with it, one little thing that makes it actually not. Oh, hold on, I'm going to sneeze. All right, edited out a sneeze there. What you will find here is that there is actually one slight difference between the for loop and the while loop. You'll notice that I've initialized a variable here. I've created a variable here, and then I have to recreate it down here. That's the one thing that's different. So if I do a system out print line count down here, oops, system out print line count, that's fine. That will print out whatever count is at the end of the loop. So count it, there's one more plus plus before it exits, so I'll get the 11 here. If I do a system out print line count here, it's not going to work. Okay, so there's a very slight scope difference. It's almost as if this whole for loop is inside of its own block. So even though, you know, this is it's as if it happens above the loop, actually it's more like this. It's more like there was a code block right here, like that, around the whole thing. So now this is now exactly equivalent to this with the block around it. So what that means is, if you remember the scope discussion, the count variable here is only accessible inside this block and is no longer accessible out here. Okay, so it's not exactly equivalent. Control-Alt-L to indent that back. It's not exactly equivalent to the while loop, but actually this is a really useful property that once this variable is finished with in the loop, it gets disposed of. If you wanted to use it later, you would have to initialize it up here and then assign it here. And that, now we can do that. Now we can print the count. So if I run this now, they will both appear to count to 11. Oops. Oh, right. Now I have a new problem in my code because I've now declared this variable inside this block. I can't redeclare it here. So I actually have to tweak my code a little bit more to make this particular piece of code actually run. But there, you can see they both count to 11 now. Okay, so yeah, let's put things back the way that they were. There we go. So you can generally think of the for loop as equivalent to a while loop like this, with the one caveat that the scope of this variable is different. If you declare a variable in the initialization here, it will not be accessible outside of the loop. Okay, the only other thing I wanted to show you is that because we have graphics, we can do animations. So if you take a look at, there's this new template here. Remember the old one was called the FX graphics template? This one's called the FX animation template. And the way this one is, it's very similar to the graphics template, except that in the start method, the graphics template says your code goes here. This is not where you put your code. It starts this thing called a thread, which calls this function called animate, which is down here. So your code actually has to go inside of this method now. Other than that, it's the same. So what you'll see is in our old way of doing things in the graphics template, we did all of our code first and then the screen popped up. What you'll find here is that the screen pops up first and then your code runs. Whoops, Control-Shift F10. So there you go. So if I put code here, it works pretty much the same way, or you can think of it as working the same way. Let's do fill oval, 100, 100, 50, 50. So we'll draw a black circle in the middle of the screen. Don't show this again. Stop and rerun. There you go. So if you're just doing regular drawings, you can think of it as working the same way as any other thing. But what's cool about this is, let's make a for loop here to animate this thing. So for x equals, we'll start at x equals 0. We'll go up to, I don't know, 400, and we'll add 1 each time. And then, whoops, and then we'll put this inside the loop, and we will use the x variable here as our x coordinate. So what this is going to do is, this is going to draw 400 circles in slightly different x locations each time. This isn't really an animation, but it's getting there. So there you go. So what it did was it drew 400 in a row. If we want to actually see them animate, we have to slow things down. There is a pause method down here that calls thread.sleep. There are technical reasons why we can't easily use thread.sleep directly up here. You'll notice it's inside this try catch block, but don't worry about that. So what we can do is we can call pause. Let's do 1,000 divided by 60. So 1,000 milliseconds in 1 second divided by 60 should get us approximately 60 frames per second. So now we should see it go. There it goes. So it's growing across the screen. Now if we want to actually make it move across the screen, we're going to have to clear it. So the easiest way to do that is set fill color white, and then GC fill rect. We can just clear out the whole screen. How big is the screen? It's 400 by 300, so a width of 400, a height of 300, and then we will have to remember to set the fill back to whatever color we wanted. Let's make it red just to be different. So Okay, this isn't quite going to work the way we want it to. You might see some kind of a flicker happening here. But the basic idea is you draw the screen, you pause, and then you clear the screen and redraw it. So what we really want to do here is something more like this. Put the pause there. So draw, pause for a little bit, and then clear the screen. Then we go back and increase the X and draw it again. Hopefully this will work. There we go. Little red ball moving across the screen. Fun. Okay. Oh, I did that inside the animation template. I should have copied that into a different file, but that's okay. There's a pre-baked simple animation here. If you run this, oops, not that. If you run this, you get to see it says animation is fun, and then it makes a little ball move across the screen here. This is using the animation template. This is the animate method. It actually starts at x equals -200. So it's pretty much the same as what I showed you. If you want to make your animation go faster over in my animation template, I can decrease the amount of time I pause, or I can just go move it by 5 pixels instead of by, oops, I keep pressing the wrong button. I can move it by 5 pixels at a time instead of 1. Now it's going 5 times as fast across the screen. So the simple animation here clears out the whole screen and then draws the unchanging parts and then draws the ball. So it has to keep redrawing animation is fun in order for this to work, and then it pauses for 10 milliseconds. There's also this happy face animation, which is based on the happy face program that we did before. This might be a little bit beyond where you guys are at, but it's kind of fun. This is done again with the animation template with a single loop. So that's kind of fun. Okay, so that's the basic idea behind animation. Again, is draw the screen the way you want it, pause, clear the screen, and then redraw it in a different place, in a different configuration, right? So I have a bunch of exercises for you that are based on for loops, because a for loop is a natural loop to use for this. Anytime you're doing a counted loop, where you're just going like on one variable from like 100 to 200 or whatever, it makes sense to use a for loop. That's when programmers tend to use them. So here I'm just, because it puts all the logic right here. I can see that I'm going from x location 0 to 400, going by 5s each time. And I can just change this whenever I need to, and I can put the variable that I need. I can use the variable down here. Okay, so if we go up to the exercises, here they are. My suggestion is that you try one of these ones here. So modify simple animation by adding a for loop and making other necessary changes so that the ball bounces back. So it starts, I had the ball going to the right. I guess for you guys it would be this way, maybe. Have it bounce back by adding a second for loop after it. Second one, make a shape slowly fade out. So you can do that by modifying the red, green, and blue values of its color, right? So if it starts as red on a white background, it might be 255.00, and white would be 255, 255, 255. So make your variable go from 0 to 255, and you can make the thing fade out. We can go through some of these in class. Make a shape grow or shrink. So use a counted loop to set the size of the shape. Try to keep it centered as it grows and shrinks. That's an extra little challenge. And then if you really want to go nuts, it says here, using FX animation template, make a more complex animated scene, such as a fireworks display. Do I have one of those to show you? Exercise 1F, maybe? No, exercise 2F it would be. Yes, I do. So let's copy this, and we will paste it over here. So there's solutions for all of these, but try them on your own before you look at any solution code. It'll just you'll get a lot more out of it if you do that. The point of this is for you guys to run code, to write your own code, and to spend as much time as possible writing your code. So here's my fireworks display. Just a bunch of loops controlling shapes. Boom. There it goes. Fun. Okay, so that's a loop which is moving multiple things at the same time. So that's a little bit tricky to work out, but it's definitely a good little logic and geometry challenge for you to make that work. Okay, but I'd be happy if you could just make one thing go up and then explode. That would be really cool. I used methods. I defined my own methods and stuff for that. Okay, so that's it. You have some exercises to do. We've got a for loop. We're animating things, which is always fun. Make sure you're using the animation template if you want to do that. If you want to do that, you can't do it with the graphics template for technical reasons, but you can do it with the animation one. And I will see you in the next video.